third law of thermodynamics states that the system cannot have its absolute temperature reach zero. Zeroth law we talked about a little bit, so I'll skip over that. We got the first law good. So the second law talks about that. So then we get less useful forms of energy transfer from the two. They originate from to less useful forms of energy in a natural process. From high quality energy tends to transform into lower quality energy. Energy tend to disperse. Entropy is the natural dispersing or degrading of energy. It's measured by the amount of disorder in a system. So let me get the basic premise for you. Okay? So two things for this summary here. So the third law says you can't reach absolute zero. And remember, the reason for this is energy is conserved. First law. Okay? So any temperature change, any internal energy change has to be related to the work done and the heat transferred. Okay? Second law, heat goes from hot to cold naturally. That means that if you want it to go from cold to hot, like lowering the temperature to absolute zero, you have to do work. The closer you get to absolute zero, the more work you have to do, and it's impossible to do that much work, and so therefore the third law, you can never actually lose absolute zero. The other one is entropy explains why energy degrades over time. Okay, we talked about when heat is transferred, some of it is turned into work, some of it is turned into internal energy change. When you rub your hands together and your hands get hot, I can put them on my face and they feel mildly warm. But all the work I did to increase that temperature, that does not all go into transferring heat into my face. Some of that changes the internal energy of my hands. What can I do with that internal energy? Nothing. Can't do anything with it. It's useless. I can't do anything with it anymore. Because you can't turn all of your heat into work, you're going to lose some energy. Not lose. You're going to turn some energy into unusable. The book uses the word low quality, or it uses the word to like unuseful forms. I like to use the word unusable, so it turns into unusable energy. A great example of this is white dwarfs. Okay, our sun is going to die. When we get to astronomy, we'll talk about this. Our sun is going to die. When it dies, it's going to turn into a white dwarf, which is a really, really, really dense, hot ball of carbon. At that point, it doesn't do anything. Like, it doesn't release enough radiation. It doesn't do any additional form of energy. It just releases heat, and it changes its internal energy. But it loses a lot of that. And so that is unusable form of energy. Like, at that point, it's just eventually going to turn into a like dark husk of stuff that you can't do anything with. Okay, and that's this idea of entropy. Energy degrades over time. All right, good. What law? We talked about the zeroth law here. I'll get some other questions in here in a second. We talked about the zeroth law already. Let's do this. So what is entropy? And entropy is unusable or degraded energy. So entropy is this idea of unusable or degradable energy. So why does it matter? It explains why heat goes from hot to cold. Okay, so things that are hot generally have more energy, therefore more usable energy, and it transfers into colder objects which have less energy, and it changes their internal energy, which makes it kind of degrade over time. So it explains why heat goes from hot to cold, and why you can't turn all heat into work. Okay, here's the clarification part here. That's going to go into more of this too. Energy is the measurement of disorder in a system. When energy freely transforms from one form to another, the direction of transformation is towards the state of greater disorder, and therefore towards one of greater entropy. Entropy also means the degradation of energy. So if you want a simpler, shorter version of this, basically, as heat transfers, it always becomes less organized, more disorganized, more degraded, less usable over time. So every time that you do this heat transfer of energy, you lose some of it. And again, it's not magically disappearing. It's just turning into a form that you can't do anything with. Okay? You slide a trash can across the floor. What happens to that work that friction does? Turns into heat. What can you do with that heat? Nothing. It just turns into internal energy. Nothing can come from that. I can't magically scoop up all the heat off of the floor and use that for something else. So energy becomes less organized and more degraded over time. For example, when the universe first was created and the first stars formed, those stars were all purely hydrogen, and that was it. They had nothing else inside of them. Those stars died and exploded and created more elements, but there's less usable energy available. So the stars become smaller and have more complicated consistencies. Those stars all died and exploded and created more elements that existed. But again, less usable energy overall. Some of the stuff is just floating out in space. You can't do anything with it. Our sun is a third generation star. And here's your diagram. So what, this is gasoline into a car, and then the car does stuff? I like it. Okay. Kind of another way to show the heat transfer idea.
You need like a summary of the clarification.
Yeah, a summary for the clarification is entropy. I'll say that energy always degrades over time. Even if work is done. So in other words, again, it's not lost. It's just not something you can use. Pretty good.